right, welcome everyone. We'll give everyone a few minutes here to kind of trickle in before we get started. I want to welcome everyone back. It's been a couple weeks since we've had a webinar here in the LTC web and webinar series. My name is Brian Bates. I'm the Director of Professional Learning with the LTC, and I'm joined today by my wonderful colleague Joe Cipfl. He'll be talking a little bit today about 3D printing fundamentals. But before we get started, as people kind of trickle in here to the room, just a couple of reminders about our webinars. It's being recorded today, and it'll be available shortly after the session concludes. The address is right there on the screen, ltcillinois.org/events/webinars. If you scroll to the bottom of that page, you'll find the on-demand recordings of not just this webinar, but our past webinars from this school year. You can also check out some upcoming webinars that we have through the rest of the school year, which is rapidly approaching here shortly. Also, attending this webinar today will be worth PD credits. So tomorrow you will receive an email from me with an evaluation. Once you complete that, you'll be sent your professional development credits for attending today. So if you don't get that from me by tomorrow afternoon and you check your spam folder and you don't see it, then let me know and I'll make sure you get your PD credit for attending today. If you have any questions for Joe at all during the session today, please throw them in the chat. Make sure you change it to everyone that can see your questions. That way we can all kind of keep an eye on what questions are being asked and we know what questions that Joe is answering. You can also use the Q&A feature if you'd like, but the chat's probably easiest for us to keep up with. Without wasting any more of your time, I'm going to go ahead and turn it on over to Joe. So Joe, welcome and thanks for joining us today.
Thank you, Brian. Thanks everyone for being here. We're going to talk a little bit of 3D printing today. Let me share my screen with you. Let's get going here. Okay, so today, as I said, we're going to talk a little bit of 3D printing fundamentals, just the basics of 3D printing. Really, there's a distinct possibility there might be 3D printers in your building right now, just simply collecting dust. So if that is the case, this is certainly a great starting point for you. Also, if your district is considering making some EdTech purchases this school year, especially with stimulus money coming in, this might be a great time to make those purchases. Let me guide you and start you on that process. So my name is Joe Cipfl, as Brian said. I'm the Regional EdTech Coordinator for Southern Illinois for the LTC. So I work with 8 ROEs and 170 school districts and about 5,000 teachers in Southern Illinois. And so it's literally my job to support you. So if you have any questions, if you need guidance or anything after our session today, please feel free to shoot me an email. You can follow me at LTCJoC also on Twitter, but I'm here as a resource when you need me. Additionally, don't forget that LTC offers a wide variety of professional learning. We have great online courses. We have our webinar series like this one. We've got a great online community. You can sign up for our newsletter or just simply follow us on social media. And if you're just looking for PD, just go to our events page. There are several regional coordinators just like me. We have statewide staff. We're all doing tons and tons of professional learning, most of which are free for you. So definitely make the LTC a resource. Okay, so let's get into it. What I can tell you is this. If you are ready to take your technology integration into your curriculum to the next level, 3D printing is certainly a great way to do that. And the time really is now. As I was saying, there is definitely some money coming into school districts where school districts are going to have some freedom to make those kinds of purchases. And so just to give you a little bit of background about me, for 20 years, I was a middle school biology teacher, and I am absolutely kicking myself that I didn't integrate 3D printing into my curriculum those last few years that I was in the classroom before taking on my current role. It has so many applications to that life science curriculum that I was teaching. And not even if you're a STEM teacher. STEM teachers obviously have unbelievable avenues to integrate 3D printing into their curriculum, but even some of those humanities classes and some of those language arts classes have great opportunities to integrate 3D printing even into those subject areas as well. So I'd like to break down our topics into 5 main categories. Now, this is a webinar where I'm going to introduce all of these topics to you. But I also do in-depth hands-on workshops where we cover these topics in much greater depth and we get our hands on the printer. So if this is something that has interested you or piques your interest, please seek out some of that future PD that we offer. Okay, so we're going to talk basics, just the basics of the printers and the printing process. We're going to talk then about software and apps to create your models and to prepare those models for printing. We're going to talk about how to create a workspace that's conducive to that hands-on inquiry-based kind of learning. We're going to talk about some printers that are best for education. I've done a ton of research. I've tested some printers, and so I've got some recommendations for you. And then finally, we'll wind up with some tech curriculum integration stuff and some classroom resources to get you started on the process itself. Okay, so let's just get into the basics. So let's start with the most basic. What is 3D printing? Well, 3D printing is a manufacturing process, and it is a process in which layer upon layer of an additive material is laid down in a 2-dimensional environment to create a 3-dimensional structure. And most of us think of 3D printing as a new technology, but honestly, it's about a 35-year-old technology. But about a decade ago, patents started to expire, and so it opened 3D printing to a much wider audience and really pushed it into the realm of education too. So what you see here on slide number 8, one thing that I did do is I did put a link to this slide deck in the chat. So please follow along. Please use this as a resource after our webinar today, because there are just loads of links to a ton of material. So please use this as a resource after our session. But take a look at this little video here on slide number 8, and you can get a real world view of that additive layering process. And you can see that those layers of plastic are being laid down one after another to create this 3-dimensional frog. This is one of the printers that I'm using right here, and this is a video that I shot. That type of printer is known as a FDM printer, fused deposition modeling, where layer upon layer is laid down to create a 3-dimensional object. Think of it like a glue gun, so to speak, where a plastic filament is fed through an extruder and through a heated nozzle where it lays down that melted filament, where it cools quickly to create the structure, laying it down on a print bed. And so you can see the specs there on slide number 9. So really you can break down the process into 3 basic steps. And so first, we start with a model, a 3-dimensional model. And so that 3-dimensional model of an object is generated through a modeling program, typically CAD software. And we'll talk about that in just a bit. That's step 1. Step 2 is that 3D model is then sliced using a slicing program to create those layers that the printer uses to build that structure. And then the third step is that the printer lays down the filament to create the object. And so those 2D layers stack one upon the other to create the 3D print. Now, to just expand on that a little bit, here is a great way to think of it. Think of 3D printing in 3 easy steps. First is design. So in order to get that 3D object, you have to start up with a design. And you can really do that a few ways. Commonly, that 3D object is created in CAD software, computer-assisted design software. Or you can 3D scan a physical object. And we're not going to talk about that today because that certainly isn't a very much advanced concept in 3D printing, but you can certainly move into that once you get the hang of 3D printing. And really a super, super common way that people get those 3D files to print is by just finding them on the internet. There are great repository websites like Thingiverse and Prusa printers out there where you can get great 3D object files that you can then slice and print yourself. A good example is my Darth Vader Buddha right here. This is a file that I found on the internet and printed up. Okay, so once you have your 3D file, you need to slice that file. So step 2 is to slice it. So before you can print that model, that 3D object has to be sliced into tiny little layers so the printer knows where to go. So that 3D file is known as an STL file. That's just its file extension, STL. That slicing program splits up that STL file into layers. And then that tells the printer where to output. Think of it as kind of like a Etch-a-Sketch is a great way to think of that. 3D printing is just adding a third dimension to that Etch-a-Sketch that you may have played with as a child. So what do you have to do to slice that 3D object? Well, you have to use a slicing program. And there are great open source free slicing programs out there like Cura and Prusa Slicer, which are really, really good. I've used them myself. We'll talk about those in just a bit. The last step, step 3, is printing. So now you need to send that sliced file that basically when the slicing program slices the file, it creates what's known as G code. And you have to save that G code and send it to your printer. Then the production process begins. And so that could be a matter of minutes, that could be a matter of hours, that could be a matter of days. The printing process obviously is slow, and the thinner your layers are, the more detail your object has, the slower or longer that it takes. My Darth Vader here took about 7 hours to print, just to put that into a little bit of perspective. Okay, so let's get beyond the basics a little bit. So let's talk a little physics. We need to talk about the X, Y, and Z axis because that is exactly how a 3D printer works. So that extruder that is extruding the plastic to create the object moves across those X, Y, and Z axes. And so as that extruder is moving, it is extruding the plastic and building the object. And so those 3 axes moving in conjunction with one another can create both organic and geometric designs. Now, the way that most 3D printers work, the most FDM printers, is the build plate where the object is built upon moves back and forth. And so that is back and forth across the y-axis. And so then the Z and X axis is where the gantry at the top of the printer moves side to side and up and down. And so you can see that in this diagram here on slide number 12. Build plate moving back and forth, and then the extruder moving side to side and up and down. There are some printers where the build plate moves up and down. It really depends on the printer, but the vast majority of printers operate like the ones you see here on this diagram. So the printer here that you see on slide number 13 is a great example of that. This is a great printer made by Prusa, and that build plate is moving back and forth, and then you can see the extruder where the filament is fed into it moving up and down and side to side. So I've got some 3D printing terminology here on these slides. So there's certainly, quite a lot of terminology, and I'm not going to bore you going through this one by one. But as I said, this is a great slide deck to use as a reference. You explore the slide deck after the session today. And you can certainly use these couple of slides as a cheat sheet when you need to figure out what all of this terminology is. And so you can see that on slides 13 and 14. On slide number 14, that's another great printer made by FlashForge, and that has that same setup. Build plate moving front to back, and extruder moving side to side and up and down. Okay, so let's next talk about the components of a printed object. And we got to start with infill. And so what infill is that internal support created in an object. It can be honeycomb in shape. It can be rectilinear in shape. It can be a gyroid, a curved shape. There's lots of patterns for infill. Some objects have better infill patterns for, organic pieces or geometric pieces and so forth. So you have to experiment a little bit. But infill is structured or measured through density. So a 5% infill versus a 10% infill versus a 50% infill is what you can see here on this graphic on slide number 15, all the way to the left here. So you can see that, a more dense infill is going to create a stronger object. So if you have to create a structural object of some kind, you're going to want a denser infill. If it's just a figurine or an object, something like my Darth Vader here, you don't need a ton of infill simply because it's not a structural piece. Okay, next term is layers. And so those layers are the things that actually create the shape of your 3D model. And those layers are built one upon the other, and you can control the layer height when you're printing. A thicker layer height is going to create a less detailed object. A finer layer height is going to create a more highly detailed object. But just remember, the thinner your layers, the longer the print takes. Just to give you a little bit of reference, my Darth Vader here was printed at a 0.15 millimeter layer height. That's a pretty fine detail. And you can see here, if you look at that object here on my webcam, there is quite a lot of great detail there for that printed object. But remember, the finer the detail, the longer it takes. And if you're building just structural objects that don't really need to always look super finely detailed, you can certainly make that layer height thicker. Okay, next we have shells. Shells are those outside walls of the printed object, the perimeter, so to speak. And so the thicker the wall, the stronger the object. But sometimes you want to print things that might have a little bit of give or flex. So in that instance, you're going to want to make those walls thinner. Next, we have rafts. Rafts help hold the printed object down to the print bed. Lots of times when you're printing a 3D object, there's not a lot of surface area to stick the object down to the print bed. So you add a raft, which is a temporary object that you pull off of the print at the conclusion of the print, but it will help adhere that object to the print bed, and just you'll end up with a more secured object, which then creates a better printed object. But those rafts are temporary structures that help to support the 3D printed object. Now, speaking of supports, let's talk next. We're going to move down here to slide 16 to talk about overhangs. So overhangs are those objects that hang into space, over space. So think of an overhang as like the crosses on a capital letter T. So if you have an overhang that's a greater than about 70 degrees or so, it's going to need some support under it to hold it up during the printing process, because you can't print out into space. There has to be an object under the printed object to support those layers as they build one upon the other. So when you have overhangs typically that are greater than about 60 degrees, you need to add supports. And that takes us here next to the next picture. Supports are temporary kind of scaffolding or grid-like structures that are temporary. They're removable after the print is completed, that hold up those overhangs, because if you don't, you get droop. Remember, it's melted plastic. And so that melted plastic cools very quickly, but sometimes not quickly enough. And so if you don't have a support under it, it could droop, and then that obviously could affect your entire overall print. Lastly, we have bridges or bridging. Those are the undersides of a print that are not supported from underneath, only on the sides, where it's not supported in the middle. So depending on your printer, some printers can print longer bridges and some can't. But the rule of thumb is generally about 50 millimeters is as long as a printer can bridge without a support underneath. So these are all design considerations. And this is the great thing about the 3D printing process. It's an amazingly experimental process where you can do lots of trial and error as you move through the 3D printing process. And that is amazing for critical thinking in your classroom. Again, it make it a learning experience. Now, if this feels overwhelming to you, all of these settings, remember that all of the slicing programs out there have default settings for the different materials. So just use those default settings first until you get the hang of things, and then you can start making little adjustments to improve or to degrade your print. And then that is great for the experimental and the visualization process of the 3D printing curriculum. Okay, now let me give you a little bit of an example of bridging and exactly what that means. So I got this great little video that I took from one of my printers of this torture test, this double helix torture test. So it makes this great double helix bridge. And you can see here, if you watch this video, just watch for a moment and you can see in just a minute how it's going to lay down a line of filament to bridge that space right there. And that's how it creates that next step. And so that width can only be so wide, roughly about 50 millimeters, until you need some support underneath. Otherwise, that step would sag down, and then that affects every layer then built upon it. So those are just all kinds of design types of considerations. Another one is supports. Here's a great example of a Triceratops skull that I printed up on one of my printers. And you can see there that there's lots of organic shapes there. There's lots of organic shapes, but that overhang under that Triceratops jaw would certainly not be able to exist just hanging into space. So there has to be a support under it. So after the print concludes and is done, you just take that off the print bed and just remove those supports away until you have your finished product. And so again, that's just an example of how supports and bridging works. Okay, now speaking of that melted plastic, let's talk filament for a second. So filament is the plastic 3D printing material. So we're talking about FDM printers today, and those are, like I said, those are filament deposition printers, and so, or, I'm sorry, fused deposition printers, and so they use filament. There's a type of 3D printing called SLA printing, which is resin-based printing. We're not talking about that today. So let's talk about these spools of resin. I'm sorry, these spools of filament that you use for printing, because there are a few different types of plastic, some much more conducive to classroom use and some not. All right, so the single most commonly used 3D printer filament on Earth is PLA. Now, I'm not going to get into the technical names of all of these plastics. I was a science teacher, so I know how to pronounce them, but I'm not going to bore you with those names, and I haven't memorize them yet. So we're going to just go with initials today. Um, So PLA is the single most commonly used 3D printer filament on Earth. It is what you will use in your classroom if you're 3D printing with your students 95% of the time. It's probably all I would use if I was using it with my 7th grade students. It's easy to print with. It has a lower print temperature. It doesn't give off any sort of fumes or weird smell, which certainly could be an issue in a classroom. It is odorless. And so it's really that go-to printer filament. The only downside of it is that it doesn't have a huge heat tolerance. So if it's exposed to heat, like inside a hot car, for example, it's not going to melt, but it could droop, it could sag, and those kinds of things. So you have to be careful with it in that it's not quite as strong as some of the other filaments. It can also be a little bit brittle. So it is sometimes easy to break things that you make with it, especially if they're put under stress. So PLA is not one that you use a ton if you're making really, really strong structural objects, but it's great for sculpture, for models, and things like that. PETG is good, PETG. It is it's stronger, it's a little more flexible than PLA. It would be kind of my second go-to printer filament in the classroom. It's kind of the middle ground between ABS, which I'm going to talk about next, and PLA. ABS is thought to be really strong. It's great to use, but it has a really high print temperature. The layers don't adhere to one another all that great without an enclosed environment where you can elevate the temperature, and it gives off a funky smell and potentially hazardous fumes, and that's definitely not going to be classroom friendly. So PETG it fills that middle ground between ABS that's strong and PLA that's easy to print with, and without the fumes or any sort of difficulty in printing, because printing with ABS can certainly be tricky, and it's typically for a more advanced printer. TPU is great. It's a flexible material. So like if you're making model cars or something like that, you would make the tires out of that. But it's notoriously difficult to print with, so definitely an intermediate to advanced type of material. Nylon is great too, but again, it's like ABS. It can give off fumes, but it's super strong. So if you are if you're a CTE teacher, for example, you might want to print with nylon because you might be printing structural objects with your students in a shop-like environment. Where that would be ideal. I mean, if you're in a well-ventilated space, if you have a ventilation hood of some kind, you could certainly make the jump to ABS and nylon to test for strength and structure. Okay, so let's move into the second part here. Let's talk about some of the apps and tools and software that you're going to use during the printing process. Okay, so where do you get these 3D printable files? Well, you can either download pre-designed files from the internet, and I'll share some examples in a second, or you can create those files in CAD software, computer-assisted design. So let's talk first about downloading the models. The go-to repository on the internet for STL files, those are those 3D object files, is Thingiverse. It's awesome. And so there are others, but Thingiverse is certainly the best. But again, these are open source STL files, the vast majority of which are free, and you can download them on the internet. So here are probably the top 4 repository sites on the internet. We've got Thingiverse, and that is ahead by a mile. It's got 1.9, I think by this point, just about 2 million STL files available. You can find all kinds of great stuff. Everything that I've printed so far, I have found on the internet. I've not made the jump myself into the CAD software. I'm learning one thing at a time here. So I am still downloading from the internet, but I have found all kinds of amazing and cool things, not just gimmicky little, you know, Darth Vader Buddha models, but structural things and things that are useful for my household and in the classroom as well. Cults is really good too. Pin Shape is another really good one. But probably my second favorite is the Prusa Printers site. Prusa company makes awesome 3D printers, and I'm going to talk about them here in a minute, but they have an amazing international online 3D printing community. And Prusa Printers is kind of the new kid on the block here when it comes to these repository websites, because they just started that website in 2019. But it is excellent. And the files are very well organized and very well researched as well. Now, some of the tips when it comes to downloading files is, first of all, when you download those files, definitely load them into your slicing software and take a close look at how everything looks, and make sure that there's no layers like hanging out into space that won't print or something like that, or there aren't any flaws in the print. These are designs from common folks that are, you know, just putting them on the internet. So they're not always going to be absolutely perfect. Go to the education section. All of these websites have a great education section. Thingiverse has an amazing education section. And so definitely check that out. Another thing too is to read the comments, because since people are placing these files onto the internet to download, you can leave comments on them, or you can, you know, even upload pictures when you build that object and show it off. But many times these designers will communicate with people in the comments, and so they'll offer recommendations and suggestions and how-to information. So definitely check that out. Okay, let's talk next about CAD software. So let's say you want to actually start designing some things and get your students into creating the 3D models in the first place. Well, you've got some great options that are free, open source, and are excellent for kids. And so probably the best open source free design software out there, and it's web-based, is Tinkercad. Tinkercad is excellent. It's an Autodesk product. It is free, and it is an amazing tool for educators to get their students started with 3D design. And it even has Google Classroom integration. So if you're using Google Classroom with your students already, Tinkercad has that integration, so you can share Tinkercad information and links right there in Google Classroom simply and easily. Students create their accounts with a single sign-on with their Google account, so it's safe and secure as well. So Tinkercad is definitely going to be your go-to starting 3D design, even for adults too. It's a great community that you will definitely see, if this is something that is interesting you, you will definitely see that there is an amazing community of people out there in the 3D printing world that are very eager and willing to help. Everything that I'm telling you right now, I learned either via social media or in YouTube videos. So if I can do it, you can certainly as well. Okay. So SketchUp is the next one to talk about. It's very, very good. It's a little bit more advanced, and it really wouldn't be my next logical step if I was using Tinkercad. If I was using Tinkercad and then I got through it and I started to understand it and I kind of got past that learning curve of using it, my next logical step would really be to move to Fusion 360. Fusion 360 is another Autodesk product. It is a subscription-based, but you can get free accounts if you're an educator or a student. So they offer free accounts for educators and students, and Fusion 360 is amazing. I mean, it is legit professional level CAD software, and certainly would be the next step after Tinkercad for both students and educators alike. And then after that, you could certainly then move to Mesh Mixer, which is really state of the art. It is totally free. And what it does is it's kind of, it has this nickname of the Swiss Army knife of 3D printing. It allows you to really fine tune your 3D models. And so you'll see that oftentimes you can use successive pieces of software as you're creating these objects to just fine tune it and make it look even better. But start with Tinkercad because it is the great first step, and it's super easy to start with. Okay, now let's talk next about what software you're going to use once you have this STL file, once you have this object file. Now you need to slice that file. You need to tell the printer how to build this object. So what slicing software does is it takes that STL file and it converts it into a series of thin layers, and that produces what's known as G code. And G code is just the code in which the 3D printer uses to create the object. And so that basically tells the 3D or the printer extruder where to move in space, where those linear movements are. Okay, so there are a few design considerations to think of when you're slicing this object. And so these are all several links here. So if you're looking at slide number 31, I'm not going to go through these one by one, but I would like you after today, as you're moving and progressing through this, these are all things to think about when you're slicing that 3D object in order to build it. Like model orientation. How are you going to place that object on the print bed? You want to look for the biggest, widest, flat area for that to stick down to your 3D printing bed. You want to have as large of a surface area as possible that sticks down to your bed that you build upon. You need to then consider support material. Are there overhangs that are unsupported that you need to place those temporary supports under? Remember, all of these printers have default settings. So just set that at default at first, and then you can start tweaking things once you get the hang of things. You need to think about print bed adhesion. How's your object going to stick down? You need to think about your resolution, how thick your layers or how thin your layers are going to be. Remember, thinner layers gives you more detail, thicker layers give you less, but thinner layers require more time to print. You need to think about your infill, this internal support. Is it structural object? Is it decorative? How much internal support does it need to support that object? Think about your print speed and your temperature. Some filament has different temperature settings, and so you can tweak your temperatures up or down to improve the quality of your prints. And then finally, you need to think about calibration, and that is how the print head is calibrated to the surface of the extruder is calibrated to the surface of the print bed. And so you can make little adjustments to your calibration to make that very first layer that it lays down really high quality, because that's your base layer and everything builds upon that. The 3D printers I'm going to recommend today have auto leveling and some auto calibration, and that is a key feature that you want to have on a classroom 3D printer. Okay, now just to give everyone a little bit of fair warning, I'm probably going to go till 4:30 today. I certainly understand if you've got to bug out at 4:15, because typically these webinar sessions go for 45 minutes, but I just can't get through this in 45 minutes. So if you do have to bug out, I certainly get it and understand. Please take a look at this reference material after today, but if you can stick with me till 4:30, it's certainly going to be worth it. Okay, now take a look here on slide number 31. So I'm talking about all of these design considerations, and what you see pictured on slide number 31 is a test print. There are all kinds of calibration type of test prints that you can print up to see exactly what all of these tolerances are on your particular printer. If you have a higher quality printer, it's going to be able to print overhangs better than a lower quality printer. So you can print these test prints to see what your overhead threshold is. Well, my printer can't print anything after a 70-degree print. So anything that has a greater than 70-degree overhang is going to require support. So then I can enable supports for this print. Now, I do certainly understand that this all seems like a lot, but as I said, your printer has default settings for the different types of filament. So always start with those default settings, print at the default settings, and then you'll be able to make tweaks and make changes and adjustments as you become better and as you become more practiced. Okay, so let's talk about some of that slicing software. So the two gold standards that are free and open source for slicing software is Cura and Prusa Slicer. They are most definitely the best slicers out there. I use Prusa Slicer about 95% of the time when I am 3D printing. It is open source. It is perfect for both beginner, intermediate level, and advanced printers because it literally has tabs in the program where you can click on beginner and it's only going to have so many options available for you. And then you get more practice and you get the hang of things. And you can go to your intermediate setting and now more options are available. And then finally, once you get comfortable, you can click on advanced settings and now all of those options are available and you can start really fine-tuning your prints. But you stay at the beginner level as long as you want until you get comfortable. Cura is excellent. It's made by Ultimaker. Ultimaker makes awesome 3D printers. And again, it is open source. And it has been used the longest and has been around the longest. So it's really good. I use both. I really like tree supports in Cura. Cura creates these supports for some of its prints known as tree supports, which are really, really specific and accurate. Sometimes those are great for sculptural types of prints. So sometimes the 3D printing software has better results for different kinds of objects. But what's so great about it is it's free. So you can download it very easily. Now, something to remember about slicing software is that it's an actual program that you have to install on your computer. It's not web-based and it's not very Chromebook friendly. So it's PC or Mac and it's something you're going to install on your computer. So it is a standalone program. Now, there are a few web-based slicers out there you could certainly investigate. Flash Forge Computers has one. The Flash Print slicer does have some web-based capabilities or some browser-based capabilities. But most of these slicing software packages are standalone programs that you need to install. Now, something to remember as well is that lots and lots of 3D printers have proprietary slicing software that just comes with the printer. Flashforge printers have this, Dremel printers have this, MakerBot printers have this. So it's always a great starting point. So if your printer comes with some native proprietary type of slicing software, start with that. You can always then start using Cura or Prusa Slicer. What's so great about these open source slicing programs is that you can just install your printer profile. So you just literally just click on add a printer and your printer is already there in the database. You just click on your printer and it loads your printer profile and settings into the software. Now, there are a couple of other good slicers out there. Simplify 3D is another really, really good one. It's excellent, but it's not a free software package. It is $150 for a 2 license package. Slicer also has been around for a really long time. It's actually the program that Prusa Slicer is built upon. But it's definitely an advanced level program. So it's something for advanced users. But like I said, if you've been printing for a while or you're really getting the hang of it and getting the knack for it, move on to a more advanced program. Okay, so that is the software. All right, so we got our last 15 minutes here. Let's talk about creating a workspace. We'll talk about a few specific printers that are great for education, and then I'll leave you with some curriculum resources. Okay, so there are kind of three schools of thought when it comes to preparing your classroom for a 3D printing workspace. And just remember that the location of that printer can have a huge impact on its use. And in fact, if you have 3D printers in your school building right now that are not being used, I bet they're isolated somewhere where people just don't use them or forget that they're there. So we've got three basic formats here, or layouts, so to speak. We've got the makerspace layout, we've got the general printing area layout, and then we have the instructor's printer layout. And so let's break those down one at a time. The makerspace setup is where the students work side by side with their printers and their peers, and it's super collaborative. That could also be super chaotic too. So realize that, but it is certainly the most collaborative of the setups. The general printing area is where you dedicate a space in your room to a communal printing area. And then finally, you've got the instructor's printer where students are watching a demonstration type of setup to prepare for their printing experience. So you just have to think about your learning space, how you want to set this up. I'm thinking in terms of a science teacher when I was in the classroom, where I would probably use a combination of general printing area and instructor's printer, where there would be certainly times where I was demonstrating, but I would want to have as much hands-on experience as possible. But I might not want those printers scattered around my room either, because that creates obviously a supervision type of situation as well. So, figure out what's going to work best for you. But I speaking, personally, from my experience, that general printing area would certainly be best in a, biology lab type of situation. Okay, another thing to think about too is think about that printer placement within your school building. Are they going to be classroom printers, or they're going to be communal space in in your media center or library, or if your building has a makerspace general area, where are you going to put those? Because there are certainly pros and cons to each one. So just be aware of both. Also, do's and don'ts as well. And lots of these do's and don'ts have a lot to do with your filament and your filament storage. 3D printer filament is hygroscopic. Hygroscopic materials can absorb moisture from the air. We live in Illinois. It's crazy humid here during the summertime. So it's definitely a good idea to keep your 3D filament storage stored in as dry a condition as possible. Sealed containers, sealed Rubbermaids, use a bunch of desiccates. Even there are printer dryers out there that you can use, or even just a regular old like beef jerky maker, like a food dehydrator, are excellent at keeping your filament dry. But it's really important to store it properly. So think about those do's and don'ts. Think about where you're going to place your printers, that it is absolutely stable. You want vibration-free kinds of environments. Okay, now a few tools of the trade here. So some of the most tools that you need when you're printing are things like flush cutters to cut that filament or pull out supports. Tweezers, lots of tweezers. I've used those so much. There are nozzle cleaners. They're just little needle-like structures that if you would get any sort of clog, that you can certainly fix the extruder easily. Probably the most used tool is just a regular little brass wire brush. It's great for cleaning, melted plastic off of the end of an extruder nozzle. Some post-production kinds of tools include like files, a deburring tool to pull that support material away from a model, X-Acto type knives, obviously depending on your grade level. I would not want X-Acto knives in the hands of fourth graders. But certainly those tools are important. Calipers for real precise measurements. desiccants for keeping moisture away from your filament. Super glue is certainly a go-to for fusing structures together. And it's a 3D printer that's printing constantly and vibrating all the time. So screws get loose every once in a while. And so a set of hex wrenches and a good screwdriver is certainly going to be key as well. You can buy all that, or you can just buy a 3D printing toolkit, which they have. If you just do a quick Amazon search for something like a 3D printing toolkit, you can find great kits out there that have all of these tools in one package for you. Okay, now, something to remember as well is you definitely need to make sure that you budget for future filament use. Remember, you're using filament up. So if you're creating a budget for integrating 3D printing into your classroom, you need to remember that there are future purchases that you're going to need to make. So definitely budget some for that future filament usage. You can find great filament out there, PLA filament for 20 bucks a spool. That's a 1 kilogram spool on Amazon. There are great deals out there. It is not super expensive. You could easily spend, a couple $100 and have lots of spools of filament that will last you for a long time. Okay, so let me share with you a couple of my recommendations for the best 3D printers for the price for your classroom. Now, I will tell you this, I am brand agnostic. I don't care what brands I recommend what works. But what I would certainly recommend you do is to do your research. Get out there, watch those YouTube videos that are review videos, join some social media groups on 3D printing and ask questions. There's a huge maker community out there that is super, super willing to help. So just do that research, or you can let me do the research for you, because that right there is a picture of my living room. I've spent the last year working from home, so I'm making home work for me. And so I've built a 3D makerspace in my living room. And so I've been testing out some 3D printers here now for the last few months. And so let me do a little bit of that work for you. So I'm going to recommend 5 3D printers. The very first one I'd like to recommend is the FlashForge Adventurer 3. Look at that. Look at the prices for this thing. So you have the Adventurer 3, and then you have the Adventurer 3 Lite. And honestly, if I had like a $1,500 budget or even a $1,000 budget to spend on 3D printing, this right here is the printer that I would buy. They're $299. They are auto leveling. They have a heated print bed. You can print multiple types of filament, and you're just not going to find those types of options on anything cheaper. You could literally, with a $1,000 budget, buy 3 of these and still have some money left over to buy some filament. So certainly great for classroom use. It is enclosed, so it's safe. It does have a relatively small print bed, 150 millimeters by 150 millimeters by 150 millimeters, but you're not going to be printing enormous things in the classroom. And if you are, it's going to be for a specific design type of class, where you can purchase that one large scale type of printer and then several more small scale printers. Now, the Adventurer 3 is $450. It has a few more capabilities. It's more easily networked. Well, actually, both of them can be networked via Wi-Fi, which is great. But this one, the standard Adventurer 3 has a built-in webcam as well. So you can monitor the print from the internet with a built-in webcam. Really cool. Okay, 3 more to go. The Prusa MK3S is my most favorite printer. It's an amazing printer. It is dead accurate. It is got auto leveling. It has a heated print bed. It will print any of the printer filament. it is just an amazing printer. And what's so great about it is you can buy it fully assembled for $1,000, or you can buy it in a kit format for $749 and build it yourself. So if you are a CTE teacher where you're building things as well, it's a great opportunity to build a printer with your students as well. I have this printer. Well, I have all of the printers that I'm reviewing for you today, and so I've tested them out myself. And this printer is my absolute favorite. However, that might be a little bit beyond your budget. There is also the Prusa Mini, and so that is a much more affordable printer at $349 for the kit printer. It only comes in 3 pieces, so it's really easy to put together. And again, it creates dead on accurate prints. It auto levels, heated print bed. Here's the thing, everybody. When you are printing in the classroom, the last thing that you're going to want to mess with is a bunch of manual bed leveling. That is a headache creator in your classroom. You definitely want to pick out those printers that have auto bed leveling, because that's just one less thing that you need to worry about. You're still going to be doing some minor calibration and making a few adjustments, but that auto bed leveling is so huge because it doesn't, your printer doesn't have to be on an absolutely perfectly level tabletop, because it'll compensate because it has that auto leveling built in. And the Prusa auto bed leveling, is called mesh leveling, is second to none. It's fantastic. And for $350, again, super, super affordable. The printer, the double helix bridging test that I showed you earlier in the video, that was my Prusa Mini doing that. Next, if your budget's a little bit higher and you want a high-end printer, the Dremel Digilab 3D45 is definitely the one to choose. It's $2,000, so it's definitely pricey, but it has all the bells and whistles. It is awesome. It is fully enclosed. It is fully networked, has a great interface that's all digital. It has a built-in webcam. You can operate it via the web. It's network capable. If you buy Dremel filament, it has RFID built into it, so you don't even need to plug the name, the type of filament that you're using into the printer. It auto recognizes it. It's really, really good. But again, it's probably not something that I would have used as a STEM teacher. But if I was in a CTE type of environment, this certainly would be an option for a more high-end functional kind of professionally functional 3D printer. Okay, so let's wrap up last with some resources for you. So what you will notice is that there is not a ton of 3D printing curricular material out there, but I do have some for you. But the key thing to remember here is no matter what you teach, you can integrate 3D printing into your curriculum. The STEM classes, the applications are immeasurable. But even if you're a language arts teacher, if I was a lit teacher and I had a 3D printer in my printer, I would be printing like busts of the authors that we were printing. Or, if I was reading, if we were reading The Monkey's Paw or something like that, we would print a monkey's paw. So there are so many applications beyond just the STEM and CTE curriculum for 3D printing. So I do have some options here and some suggestions on ways that you can integrate into your curriculum, but let me give you the resources and I'll leave you with that. So here are some curriculum resources. So everything here on slide 59 is a link, and there are some great resource or curriculum resources out there for you. Thingiverse Education is fantastic because those are free lesson plans. So check that out. Now, some of these are free lesson plans. Some of these are subscription-based services, like, for example, the Learn by Layers 3D printing curriculum. That's a $250 curriculum, but it's really, really good. And it's a pre-packaged curriculum, which might be a way to kind of get you started. So definitely something to think about. Don't forget about 3D printing on social media. I'm telling you, I didn't know how to 3D print 4 months ago. I didn't. I just learned. I became interested in it. I'm thinking about what is next for ed tech for teachers, especially right now after COVID and after we're using more technology than we ever have in our classrooms. I really gave it a lot of thought of what is next. And so I am new to this myself. And so the way that I learned was YouTube videos and social media. I joined several 3D printing groups on Facebook. I joined several subreddits for 3D printing. And so I've got links to all of those. They are an excellent place to go to ask questions. And you can even lurk in some of those groups just to get information, even if you don't want to participate. And then finally, here is a whole bunch of 3D printing YouTube channels. Watch them. There are great reviews. They are super educational. I can't speak more highly of the 3D printing nerd YouTube channel. It's a guy by the name of Joel Telling. He is about the same age as me. He prints with his kids. He has all kinds of fantastic ideas. He reviews printers. But again, here are some YouTube channels. Start at the top of the list and make your way down. You will find some great resource material. Okay, guys, that is about it. I have managed to keep this at 1 hour and 1 minute. So I'm sorry that I did go a bit long, but I do think that it was worth it. As I said, please know that I'm a resource. I'm here for you. This slide deck will be available indefinitely after the session today. Read through it. There are all kinds of buried links in that slide deck. Use those resources. And if I've piqued your interest here, please understand that I use this very same structure on a more intensive 2-day or 4 half-day session, hands-on 3D printing workshop, where we will go through each of these topics much more finely, experience the 3D printers, get hands-on, get experience with the software, and take a look at those resources. So again, if this is something that is interesting you, I'm going to be moving forward with several of the ROEs down here in Southern Illinois to offer some hands-on sessions from the summer and then moving into the fall of next year. So definitely look out for those and join up with those sessions, especially when we can get back to a little bit more in-person types of sessions. But again, I'm a resource if you need me. Shoot me an email, follow me on Twitter, and I'm here whenever you need.
Awesome. Thanks, Joe. As of right now, there are no questions in the chat, just words of praise. And I would add on to that, excellent resource. Learned a ton about 3D printing today from you. And I look forward to seeing what you can build off of this. So keep an eye out for what Joe has coming up and take advantage and join in on his sessions.
Just to give you a heads up, this was my very first print. And this is my current print. So that was about 4 months worth of learning. So if I can do it, anybody can.
Well, that's awesome to have you as a resource. Please feel free to reach out to him. The link to the slides is in the chat. And don't forget later on here in a little bit, if you go over to ltcillinois.org/events/webinars, you can find the recording. Please share it with anybody that you might that you think might find this interesting, or watch it again later on as you start down your path towards 3D printing. Again, thanks, Joe, and we'll see everybody soon.